Okay. Just a quick refresher. What is GitHub? It's just move this. Yeah. What is GitHub? It is a platform to host your Git repositories. And it's not the only platform. You have other platforms like Bitbucket and GitLab. Why do we need this kind of a platform? What's the reason? Let's say, so far, we've only been working on our local directory, local working directory, and making changes on our system. But let's say something happens to the system and you're going to lose all of the work that you've done. So the first use case is backing up all of your hard work into a platform that's always going to be available. It's like, think of it as storing your documents on the cloud, like Google Drive or your iCloud Drive. Anything that's on your system, there's a risk of losing it. So we put it on a platform where it's always going to be available. So that's the first use case, to make sure you're backing up your local work, backup local repositories. Local repositories is nothing else but your working directory. And then the second one, or the most popular one, is for collaboration. So let's say you are working on some experimental website which provides a lot of information, any kind of website that you're working on, and it gets popular. You have more people who are interested in adding or collaborating to it. How are you going to share all of the code that's on your machine with these collaborators? That's where GitHub really shines. So it's a collaboration tool. You can host your local GitHub repository onto GitHub, and more collaborators can add or contribute to the code over there. So that's really the use case for platforms like GitHub. So that's the second use case for collaboration. We will look at some of the most common commands that you must have heard of, but we will look at git clone, git push, git fetch, and git pull. Okay. So just a quick refresher. If you remember, when we created that working directly locally on our system and we wanted to manage it via Git, we were running a command called git init. Yeah. That's how you set up your local repository. You create an empty directory and you run git init. That's how Git starts managing your working directory. But let's say you already have something on GitHub and you want to get it on your working directory or on your local system. That's where you use the git clone command. And we will do all of this on the terminal as well. And the thing to be careful about git clone is you shouldn't be running this from an existing Git repository. So let's say we have been working on a folder called demo. This is a Git repository. Existingly, this has a .git folder. I shouldn't run git clone from here, because that is just going to create another repository within the existing repository and mess up your Git management or the .git folder. So that's the only thing that we should check before we run a git clone command. And the command to check that whether it's an existing repository or not is git clone, git status. So you run a git status, make sure you're not in an existing repository, and then go into an empty repository and run git clone there. So that's the first command that we will look at. Git push, git fetch, and pull. Let's do this. A kind of a refresher. It's a diagram that we've seen very commonly in the session so far. So going back, working directory, then you have the staging area. Then you have your local repo, and then you have the remote repo. So we've looked at these commands. So to move your changes from your working directory to staging area, the command is git add. From staging area to the local repository, it's git commit. And now to push, or to move your changes from your local repository to your remote repository. Remote repository is nothing else but GitHub. That's where your remote repository is. You have a working directory on your machine and you're trying to upload it or move those changes from your machine to the cloud. That's what your remote repository is. So for that command, for that transition to happen, we use the git push. Okay, so that's the journey from your working directory to the remote repository. Now, what happens when there are other contributors who are making changes to this remote repository? So we have the Women Who Code London repository, which is there in GitHub, and you have multiple contributors making changes over there. How do you get their changes? Because at the end, it's a collaboration tool. You want to see what other contributors are adding. That's where git fetch and git push, git pull come into play. So if you want to just have information about, okay, what is, and I'll kind of explain this in a bit, but this is at a high level. I'll go in a bit more depth about what's the remote tracking branch, and we look at the different pointers here, which is tracking all of that information. But at a very high level, git fetch will only get the information from GitHub to your local repository, okay? But it will not apply those changes in your working directory. So we will see all of this, okay? I'll show you all of this in the terminal. So with git fetch, you're only getting information that, okay, XYZ changes were committed, or there were 3 new commits or 4 new commits, but you will not see your files change over here. Nothing is changing in the working directory, okay? If you want those changes, so just being aware that something has changed is git fetch, but you actually want to integrate those changes within your working directory, that's when you run a git pull, okay? So git fetch is from just getting the information from the remote repository to the local repository. You have the information, but if you also want to apply those changes on your working directory, that's where git pull comes in. So it will not only just get all the information, but make those changes to your files on your working directory as well, at a very high level. But I'll explain this in a bit more detail. So that's what we will go through today. I just wanted to give you a bit of a refresher of what we've done and what we will cover today. So let's start with, okay, GitHub now. So it's a place to host repositories. And if you look at, like, there are 2 use cases or 2 user paths if you want to start using GitHub. So the first one is what we have right now. It kind of, we relate to that. We have an existing folder. So you have an existing local repository. And you want to move this to GitHub. Okay, I'm just going to take a look at the question first before we go into these scenarios. Local repo, okay. Yes, you can. You can git clone a part of the repository. There are certain flags that you need to add. You can say you want it only till a certain depth. You can say I only want to git clone a particular branch, and you don't have to clone everything. So yes, it's a very common use case where you just want to clone a particular branch rather than cloning everything, or you only want to clone a certain number of commits rather than trying to, because some of the repositories have a very large history of trying to trying to clone everything. So yes, that is very much possible. You just need to pass in the appropriate flags. I'm not sure I understood your question, Sherry. Yes, it's a platform to host Git repositories. Those are the nodes. Yeah, you back up your working directory, and it is for collaboration. So I'm not sure if there was a question. If you can, if you had a question, you can clarify that. Okay, fair enough. So yes, so now if, there could be two scenarios. We have something on our system, a local repository, and we want to move it to GitHub. Okay, so there's something existing, we have some code, and now I want to start using GitHub. So this is like the first one. And the second one is I don't have anything, I'm starting from fresh. I know I'm going to use GitHub. Okay, so these would be the two kind of user parts to start using GitHub. Either you just start scratch or from fresh, and you're going to just start using GitHub, and then you have something local. So we'll go through the first one, what happens or how do we manage that. So it's the first one. So you have some changes on you have a repository within your machine locally, and you want to, so that basically that's a .git folder. That's how you know this is being managed by Git. And you have GitHub here, okay? The first thing that we will do, we will go into GitHub and create an empty repository. So this is kind of your empty repository that we would create. The next thing that we need to do is tell our local repository. This then becomes my local repo. And this is my remote repo. Okay, now I need to tell my local repository about this remote repository, that this is where I want to start sending my changes, or this is where I want to start uploading my changes. For that, we need to set up a connection between my local repository and this remote repository. So we will set up a connection between these two using a command called git remote add. And I will explain this command in a bit. Okay, so it basically means I'm telling my local repository that I want to add a remote repository for it. Okay, so that's the command. You say git remote and the add command. That's how you set up the connection. So the connection is set up now, and now it's ready to start accepting changes. So at this stage, we will do a git push. That's the process in how changes from your local repository, if you already have made a lot of changes and written a lot of code, can be pushed to your GitHub repository. You create an empty repository first on GitHub, and we'll do all of that in the UI. Set up a connection. Once the connection is set up, you can start pushing your changes to the remote repository. Yeah, I can show the flags later. I can walk you through the flags. Any questions so far? It's just, I'm just trying to represent it setting up a connection. So you're not kind of pushing anything. That's where we set up this connection by running this git remote add command. So then your local repository knows, okay, this is the remote repository that I need to start pushing my changes to. Yes, that's right. We are just setting up a connection by doing, you're telling that this is the address. You're telling your local repository, this is the address, or this is the destination where I want to send my changes. And then you run the git push command. Git push command is separate. That's where you actually start uploading your changes to the remote repository. Okay, that's the first scenario. The second scenario is more simpler. If you don't have anything locally, we would first go in, let's use the same format. This is your GitHub. We would create an empty repository again over here. Okay, and this is my remote repo. And then we just do a git clone. So when you do into your local working directory on your machine, okay? So this is your machine. And you do a do a git clone, that's when your .git folder will be created, and this is your local repo. So in this case, you don't have to set up that connection because your local repository already knows that it is getting all of that from this remote repository. So no connection, that is kind of implicitly handled. You don't have to explicitly set up that connection, okay? Because your local repository kind of understands, and I don't want to add additional arrows because it'll cause confusion. So in this case, we don't have to explicitly set up a connection. When you are on your terminal and you run a git clone, so you do, the format is you do git clone and you have to give it a URL. That's how it knows, okay, this is the destination from where I need to get the changes and upload my changes. So that connection setup happens implicitly when you're trying to do a git clone. In this scenario, we don't have to set it explicitly. Okay. Any questions on these two scenarios before I just deep dive into it? Just checking anything in the chat. Okay. I'll explain two commands, which is the git remote and the git push, and then we'll go into our terminal and look at a few examples. Okay, yeah, I'll explain that one. So the recommended usage of the recommended protocol is to use SSH. You can use HTTPS, but if you use the HTTPS format, you will have to enter your username and password every single time. I have my GitHub account set up as SSH, and I can share the documentation in the link right away. You can set up your authentication to use the SSH format. So every time you run a command, it will not always ask you for your password or your credentials that, oh, are you authenticated to make changes or contribute to this particular repository? If you can see a repository on GitHub, you have access to clone it. To clone it, cloning is just a read-only transaction. You do not need any credentials or any kind of permission to clone. If you can see it, it's a public repository and you have permission to clone it. But to start committing changes or pushing changes to it, GitHub would want to see, oh, are you authenticated to contribute to this repository? Similar to, think of it like your Google Drive when you're storing some documents and you want to upload something to someone else's drive, it will ask you, oh, are you authenticated? If you use the HTTPS format, it will always ask you for your password every time you run the command like git commit or git push. That's why I use SSH. Once you set up your SSH keys, it will not ask you your password. It is kind of handled by SSH. SSH stands for Secure Shell. And at a very high level, simply without going into the deep dive of the protocol, it's an authentication protocol, which saves you from entering your credentials every time. And that is recommended. It's much more safer, secure, because you're not storing or entering your passwords every single time. You just set up your SSH key, upload it onto your account, and the link that I've shared kind of shares all of that information, how you can upload your SSH keys on your GitHub account. Once that is set up, you don't have to enter your password. That's why you see those two URLs, and when I start sharing my screen, I'll walk you through those as well, where you can find the HTTPS one and the SSH one. That's the kind of difference. Git push local repository. I'm not sure I understood your question, Chris, regarding to Git push, because we haven't covered it in that detail yet. So if you can clarify that, and I'll come back to your question. Okay, let's look at the two commands that I was referring to. The first one is git remote. So this is your git. It's a very simple command. You do git remote, add name of what this remote will be called, and the URL. Okay, this name can be anything, but the most common convention is origin. And it's like the default branch, like main or master. It doesn't have any superpower, or there's nothing magical about this name. You can use any name, but the convention is to use origin. Okay, that's the most common format, and we stick with that convention. We don't try to change that. So that's the name that you will use, origin, and the URL will be the URL of this remote repository. So this is here. That's the connection that we're trying to set. So git remote add, and this is the remote repository URL that it requires. Can you hear me? Yeah. Okay. So yeah, and then we will add the URL, and this can be both HTTPS and SSH. So we will see both the formats from the Git. We can get these URLs from the GitHub repository. That's the first command. Yeah. So origin is the convention that we follow. It can be anything, but we will stick to origin. Simple command, nothing too complicated about it. The next one. Sorry, I had a connection problem. Can you hear me now? Yeah, I'm going to look at the questions right now. You don't understand the origin. No, origin does not have any specific power. It is only trying, it's just a convention that is used. You can add any name over here. So you can do git remote add foo and the name of the URL, but you do not need any specific name in this particular case. So it could be anything, but just like for the default branch, we're using master and main. In this particular case, we just use origin. That's all. But no, it doesn't have any extension. It's just a naming convention that is being followed for the GitHub repository. That's all. Okay, yeah, that's a good question. What's the purpose of the name? Because you need to enter a very big URL over here. So every time you tell Git, and we will look at it in the next commands, Git push, Git fetch, and Git pull, it needs to know the address. So whenever you want to, it's like another alias in your phone. Like you don't remember the number always, and you give it a name. So you want to tell your local repository that this is the address that I want to send it to, and you give that address a name. That's all. That's why we need to add that particular name. Yes, that's all. So instead of adding that URL again and again, telling, okay, this is the address I want to send, you give it a particular name. Okay, we'll go into Git push now. So that's the format for the git push command. That is the remote name. And this is, like I said, most commonly origin. Okay. And then your local branch and the remote branch. Now, the most common convention when you run a git push is you want to push from origin, and the local branch and the remote branch name is same. So I'm trying to push from git push origin, main, and to the remote branch, which is also called main. So instead of duplicating this, you would see this, the format in most cases is just this, git push origin main. Okay, that's what is the most common way of running this command. I will explain sometimes. This will not happen in our use case, but again, I will explain that why or how just git push works. So you do not need these additional details. Git kind of knows or has that information that you're trying to push. So origin that's why origin is the most common name or is the default name for your remote. If it is called origin, it kind of takes, if you don't provide this information, that this is the name of your remote is set to origin. And your branch is like the same from which you are pushing to. So you can just run git push if it has been set up correctly. And we'll see this as well as an example on the GitHub repository. So yeah, those are the different syntax of running the git push command. In case if your remote name is, let's say, foo, then you need to add that name in the command. And the local branch, and so you can push to a different branch, but it is not a very common, there's no use case scenario where your local branch is called main and you want to push to a master branch, to a remote branch called foo. That's not the convention. The convention is you have a branch called main or feature one, and your remote branch is also called main or feature branch. So that's why we kind of omit that colon and duplicate the name. But I've not seen a use case where I've pushed to a branch with different names between the local branch and remote branch, but I wanted to clarify that that's the convention for the git push command. Okay, so yeah, that's git push. Now we will get into our terminal. Any questions about these two simple commands? Okay, yeah, so we will now go through both of these use cases. I will push my local repository into the remote repository, and we'll do the second use case as well, clone from a new GitHub repository into our working directory. So screen. Okay, let's begin. Yeah, so firstly, this documentation, this is where I just copied the link for the SSH. GitHub has an extensive documentation about everything. So if you need any information about how you can get started, how you can create your account, more security, more advanced features like GitHub Actions, they are very, very detailed and thorough. I can share it, but you can just Google it as well in case if you want it. That's the documentation link. And I just went into authentication from here. And that's the first link, setting, generating a new SSH key and adding it to the SSH agent. Yeah, but you can look at or refer to that documentation for anything that any specific information that you're looking for. So let's go to our terminal now. Okay, sorry. Yep, I will make sure it's big enough. Okay. Okay. So this is the repository that we've been looking at so far. Git status, nothing, everything is clean. We don't have anything else. Git branch. So I have feature one and master one. Yeah, so I'm currently on the feature one branch. Let's just switch to master and see we don't have anything there. Main, there's no master, sorry. Git switch, main. Oh, it's master. Git switch master. Okay, so we've switched our branch to master. Let's check the status here as well. If that is also clean, I will just check some git log. Okay, yeah, so that's the status of my repository, local repository. It's currently all very clean. The first thing we will do is create a new repository on GitHub. So you can use this plus sign. So I will increase the font here. So you can use this plus sign, but it depends where you are. If you are at this on this page, you can go and click this button. You can click this button to create a new repository. It depends where you are really. So I'm just going to click the first one. And I'm going to name it demo. So this is going to be within my personal account, and I'm just going to name it demo. That's what the name is. Code London. Okay, so public and private. Public is everyone will have access, or not access really, will be able to view your repository. Private is if you make this repository private, only specific people whom you explicitly give access will be able to see it. So not everyone will be able to see this repository. I'm just setting it as public. I'm not going to add a README or a git ignore at this point of time. We currently do have a git ignore in our in the local repository. So I'll just leave it with all the defaults and I'll create a repository. So you see, GitHub kind of actually gives you the options that you need to do. So we've done the first step. We created a new repository within GitHub. Now we need to set up the connection. Okay, so it gives you the two scenarios that we discussed as well. So it says, create a new repository on the command line, but I already have something. So we are following the second case over here, or push an existing repository from the command line. I do have an existing repository, which I'm going to push. So you see, that's what the git remote add command is. It tells you git remote add. That's the name of the remote, and it gives you the URL of this. Now, if you're using the HTTPS format, you see it. You can switch this or toggle this to the HTTPS. This is where you will get your URL, both in the HTTPS and the SSH format. Okay, so I will just copy this command. Go back to my terminal. Okay, How do I check what remote this particular my repository is has? So the command for that is, it's something that I didn't go through when I was making my note. It's git remote. And you see, it doesn't have anything. If you want to see the verbose mode, git remote. So it doesn't have currently a remote setup. There is no connection. This is just a local repository. Now we set the remote for it. Okay. So I'm adding that remote. Yeah. Now let's run git, the same command again. So now you see it knows about a remote, which is called origin. Okay. And if I run it in the verbose mode, so this kind of explains that this is the fetch URL and this is the push URL. So push is when I'm trying to share my changes from my local repository to the remote repository. And fetch is when I'm trying to get the changes from the remote repository to the local repository. So those are the two URLs or the two address this origin name kind of points to. So that is some additional information that you get with the verbose flow. Otherwise, you will just see the name, what is origin. We will see in the future sessions that for more advanced workflows, like when you're creating the forked repository, you will have more than one remote. So you have your local repository, but it has two addresses that it can point to. But we will cover that in a more advanced session. So so we've set up the connection successfully now. Okay. And now we will push all of these. So you look at this GitHub repository. That's what this is, right? If you look at this, it doesn't have anything. It's kind of empty. It doesn't have any file, nothing. And let's quickly go through what our repository is looking like here. So we have a few commits. Let's do an ls. What are the files that we have? We have some demo files, some 3 feature files. Okay, let's now push this. So git push origin master. Okay, one more thing that this tells you is to kind of rename it, right? Because I did mention it in I think in the first session that to avoid any derogative language, the convention now is to use main rather than master. It's just more inclusive. So GitHub is recommending that the default branch is called main rather than master. So we will just rename our branch as well. So it gives you all the instructions. We'll go here. And we'll rename this master branch as well. Okay. So now you see from master is changed to main. And now we will run the git push command. Git push origin main. Yeah, it's called, yeah, we just renamed it to main now. It was called master. My default branch was master. I've just renamed it to main now. That's all. And that's the M flag. It's a bit odd because M kind of means you move master to main. That's what that M flag kind of means, or is just renaming it. So now we just pushed all of this to our main. So again, take note of this. I will cover this when we do remote tracking branch. It says, so it did all of this, it compressed all of these files and uploaded it, but it says a new branch created main to main, okay? When we were at this page, we saw it didn't have anything, right? There was no branches in the GitHub repository. But when I did a git push, my remote repository main, my local repository main was pushed to my remote repository. So now if I just refresh this, you see, it has that main branch, okay? And it has all of these files that are over here. Yeah, just take note of this. I will explain what this means. So it says new branch created called main to main. So this means your local main, that's the name of the branch in your local repository. So now we are dealing with 2 repositories. One is local, the other is the remote. So it says the main, your local branch called main was mapped to the remote branch called main. Yeah. Okay, so again, something to note here is if I go back to my terminal, We see all of those changes, but if I see my Git branch here, we have two branches in my local repository, right? Main and feature one. But if you look at what got pushed, so I just pushed one branch, which is I said, I just want to push main. You see, you don't have any more branches here. But my local one does have two branches. So to make sure the second one is also getting pushed, we need to specify that and say, I want to git push origin to feature one. Let's do this. So now it's promoted. So now it's again said, okay, I've created a new branch. Your local feature one maps to your remote feature one. So now if I refresh my repository, yeah, it was, because when I created it, it didn't have anything. Okay. So this is your feature one now. So you see both the branches over here. No, because this is what it looked like initially. Your demo repository, it didn't have anything. This is what it was. But after I pushed those changes, this is what has happened over here. So you see main and feature one. So now you have the feature one branch as well, which has a few more files here. Is the main, so the question, is the main branch created in remote repository after executing git push? Yes, that is created in the remote repository after that command. So first I just ran. I will explain that. Yeah, there's a function. I will explain the -u flag in a bit. No. Sorry, which demo, Sherry, are you referring to? The demo didn't have anything, but I see a bunch of text. No, it did have. So if you look at the git status, there were a few files there. Git fetch, git log. You see, this is my demo folder directory, and we had all of these files there. So when I pushed, no, because when you create this, so I created this repository on GitHub. We can do this. So you will see when I create a new one in the second scenario, when you create a new repository, it's empty. It doesn't have any of those changes or code or file. That's what I mean by this demo remote repository was empty. That's what I'm trying to say. Okay, and then I pushed all the changes or the files that I had on my local computer to the GitHub repository. That's what I mean by the demo repository was empty. Yeah, correct. Okay. Yeah, it's just the instructions, but it doesn't have any files or any of the code changes over here. So we've set up the connection, but just by setting up the connection, it does not mean that you have all the changes or you had all the code. Now you have to explicitly share all of those code or those files from your local repository into remote. That's what I meant, that it was an empty new repository. Okay, I will explain the -u flag in a bit. So let's look at, that's the git remote. So that's where it's added the new feature one branch as well. And it has all of those. So we have both the two branches now. So you have to explicitly specify which particular branch you have to push in over here. Okay. Now let's try to make some changes here and we will see how we can push. Let's see what the workflow looks like. Okay, so let me just modify something over here. I'm in main. I will switch to feature one. Hit switch feature one. That is there. And let's look at what those files are. We have demo one, demo two. I'm just going to modify demo one. I'm just using the VI editor, but you can use any editor that you like. Okay. Just adding session 3. Okay. And if I do a git status now, so it says, okay, you've modified this file. Let's do git commit. Then M or so I need to do a git add demo1.txt. Let's do a git status again. Yeah, we will git committed. Add or update demo 1.5. Sorry. Update demo 1.5. Okay, that's what it is. We did the git commit now. So let's try to just do a push, okay? Git push. So you see, it gives you this message, right? The current branch feature 1 has no upstream branch. To push the current branch and set the remote as upstream, use git push -- set upstream origin feature 1. So the short form of this is just -u. It basically means that you are trying to tell Git that next time when I run a git push from this particular branch, feature 1, remember that you're going to, this is the address. The address is origin. Origin is that URL. And in that URL, the branch is feature 1. That's what you are trying to tell Git by running that -u command. So let's do that now. And you will see we will be able to run git push without giving all the details. So I will just do -u origin feature 1. Okay. So now it's pushed all of those changes, but you also see that branch feature 1 is set up to track origin feature 1. I will explain what this origin feature 1 in a bit, but let's clarify, can I run a git push now without specifying all these additional details like remote and branch name? Okay, so let's make another change to a different file. I will make change to demo 2 this time. A simple change, session 3. Okay, and I'm just going to quickly use the short form. Git update demo 2. Update demo 2. Okay, so I've kind of done it too. Yeah, I've kind of done both the steps in a single command rather than adding git add and git commit separately. I've added the -a flag so that it can both add and commit at the same time. So now let me try and run a git push. So now you see you didn't have to give those additional details like git push origin and then the name of the branch. So that's why Git kind of recommends when you look at that first documentation over here that you add the -u flag so that you can run git push without specifying origin and main. But the full syntax is git push, the name of your address, which is the remote. In this case, we set it to origin, and the branch that you want to push. So we want to push our main branch or the feature 1 branch. That's why this -u flag is being used. Okay. So let's see whether those changes have been pushed over here as well. So I pushed 2 changes. So these were all the earlier changes. We had made these changes like 2 weeks, 3 weeks ago, I don't know. But let's try refresh it. And we will see some changes were made just now, 3 minutes ago and 1 minute ago. So we were able to push those changes to this remote repository. Yeah, we covered this actually in a session, but I can share a link as well. It's there in the Women Who Code. Since you've asked, I will just share it now. We have that documentation available for writing good commit messages. If I just go into the Women Who Code London repository, Women Who Code London, and under resources, and you will find it in the DevOps section, Git and GitHub. And there's this link. I think it's in our README. Sorry, it's in the contributing guide. It's in the contribution guide. So this is here. It is how to make a pull request. Yeah. I will share this in the link as well. But yeah, it's a very good article on what's the best way to write your Git commit messages. To take a look at it. So yeah, that's how we did the Git push now. Any questions on this before we move to the next? So we've done the Git remote. So we had our changes within our local repository, and we've promoted it to a remote repository. We've set up the connection. We've pushed our changes. That was the first scenario. Any questions before we move to the next one? Is upstream same as origin? No, upstream is different. It's not the same thing as origin. Again, there's a, when we go through the forked repository section, it will make more sense because that's when we will set up a new upstream remote. It will make more sense when I cover it over there. But currently, origin is a name and upstream, it's another kind of a name that is commonly used for remote branches. But when I cover that, it'll become much more clear because you will have two remotes in that case. One is an origin and another is an upstream. Okay, so we went through the git clone command, okay, and then we did the git push command. We did the git clone first. We created an empty repository on GitHub. Then we did a git remote add. We added the remote repository URL. We set the name correctly. And then we pushed the changes using a simple git push command. We also saw how you can use the -u flag to shorten your commands so that it's always sending it to the same address without you having to explicitly specify where you're trying to push your changes to. Okay, now we will go. I will have to switch my screen. Yes, we do upload all of these sessions on our YouTube channel. -u stands for upstream. What is it called actually? Exactly. Just means upstream something. It's a flag. Set upstream. That's what the -u kind flag stands for. Okay. Yes, these sessions will be recorded and uploaded. So let's try to follow the concept first, and you will have the opportunity to refer to all of this information. Okay. Let's go. I will switch my screen now. Stop sharing this one. Okay, we'll try to understand what Git remotes are first before I go into and understanding Git fetch and Git push. So let's go into what Git remotes are. Okay. So let's just say we have few separate areas over here. So this is your local repository. This is your remote repository. Okay. And we have some changes here. Let's assume. So let's say we have a few commits here. This is my remote repository. So I'll just name this remote. This is local. Okay, and I have a few commits over here. And this is where my master is pointing. So master is pointing to this particular commit. This is the latest commit in the remote repository. And let's use main. Let's follow the convention. So let's use main rather than master. So yeah, this is the latest commit in my main branch. From here, I do a clone. To get it to my local repository. So this is git clone. And at this stage, I have all those commits. I have a main. And I have something called origin main. So this is something that we saw as well. Origin main is actually tracking your remote. It's is another way to bookmark or alias the changes in your remote repository. So origin is the address, that name you have given, in case you had given it a different name when you were adding the remote URL. Let's say when you ran the command remote git remote add, instead of origin, you gave foo. This would be foo, okay? So when you run your git status commands, you will start seeing whatever name you have given to your remote repository. We'll stick with the convention origin, okay? So when you do a clone, your main and your origin main both are pointing to the exactly same commit. Main is what is in your local, and this is tracking your remote, okay? It will get a bit tricky, so let's try and concentrate here. Now, let's say, so your main is tracking your local changes. This is your local branch, and this is what is happening in your remote branch. That's the convention. Let's say you made some changes over here now. You have this cloned, and you are making some changes within your repository in your local. This is all happening in your working. You make a few more commits, okay? What will happen to this main pointer? It will move from that commit to this new commit here. But your origin main is still pointing to this particular commit because that's what you know about what is in your remote. So this particular alias keeps track of what is happening in your, or the information that it has about this particular remote repository. Okay. So whatever it knew at the last stage, that wherever your remote repository is, it will bookmark or keep track of whatever it knows about your remote repository. So when you git clone, it knew your origin main, your remote repository main was pointing to this particular commit, and it will stay. Okay, at this point, once you've made these 3 commits, if you run a git status, okay, you will see that Git kind of gives you a message that your branch main is 3 commits ahead of origin main. That is what that message actually means, because these are 2 separate bookmarks now that Git is keeping track of. One is your local repository and the other is the remote repository. So now we're looking at kind of 2 pieces of information because you need to track both. Okay, that is what is happening in your local. Let's say there are more collaborators who are working, who have added more changes to the remote repository. So someone comes in, they add more changes over here, make new commits. Okay, this is happening in your GitHub repository, not in your local. GitHub is a collaboration tool. You have multiple collaborators making changes or adding code, and they've added new changes to that main repository. In that particular case, your main then moves from here to the new commit. Yeah. Okay, but your local repository doesn't know that it has moved. How will it know that your remote repository has updated information, has new information? That is where your git fetch comes into play. Okay, so git fetch is a very safe command. You can run it at any point of time. And if we go back to that diagram, it will only get the information from your remote repository to your local repository. That is what git fetch. It will not apply those changes. So what it will do when we run git fetch now, so let's look at git fetch, what happens here. Okay, when we run git fetch, it will get all of this information that, yes, I know there are new commits now, but it will not make those changes to your files. So what happens with git fetch here is you will have, and these are your local changes. This is where your main will point to. And now when you do a git fetch, it has information that actually there have been more changes here. And this is where your origin will point to. Okay, let me just rewrite it. This is where your origin main will point to. Okay, so that is a pointer. At this point in time, if you write a Git status, it will tell you that your main branch is 3 commits. Your main branch is 5 commits behind the origin main, because you don't have all of this information that was recently added. Okay, so it knows that there were new commits that were added, but it will not make any changes to your file. That's why it's a very safe command to run at any point of time to get the latest information that, okay, what has changed in my repository, or has a new branch been added. So 2 use cases for git fetch. One is when there's a new branch added. Okay, and again, it's something that I will show you. When you have a new branch added, and the second is when you have new commits being added. In both those cases, a git fetch command will give you the latest information. Yes, that's a pointer as well. So that points to the information about the remote repository, because they will change. Your local repository will not always be the same as the remote repository. You may make changes in your local repository and someone else may be making changes to the remote repository. That's why we need 2 different pointers to keep track. These are my local changes, and your kind of main pointer starts moving to the commits that you're making in your local repository, and your origin main. And origin is nothing but the name of the remote address that you give. It could be anything, and main is the name of the branch. So this could be origin feature 1, origin feature 2, whatever that is. So that origin hyphen the name of the the name of the branch will track the changes within your remote repository. Okay. Yeah. So that's when you do a git fetch, and git pull is when you actually want to implement those changes within your working directory. So that's when it will get all of those changes, make the changes to your file as well. So those are that's what is happening at a very high level. Git clone, git fetch, and git push, git pull will just add those changes within your repository. I actually realized I didn't cover the second scenario, which is this one. So we didn't go through creating an empty repository and cloning that. We'll cover this now. I'll just walk through this. Okay. Yes, so local repository is just on your machine. That's right. Okay. So let's quickly do the second scenario, complete the second scenario, where the second scenario, so I'm just going a bit back, rewinding, because I forgot to show that scenario. You just create an empty repository. You don't have anything. You want to start something as fresh, clone it down, and make some changes on that repository. Yeah, it's the origin main, this one. And the main is pointing to the local changes or the local repository and the origin main. Okay. So was there anything else that I wanted to talk about here? So yeah, this is actually your remote tracking branch, okay? When you do main and origin main, this is the terminology is called, this origin main is called your remote tracking branch. So to just simplify it, I'll just use another page, remote tracking branch, this origin main. Let's do this again. So let's say if you have something on your, you have a branch called main currently, and you have a branch called feature 1. This is in your local. And on your remote, where will these local branches point to? So you have a local repository, you have a remote repository, and this will point to origin main. And this will point to origin feature 1. Okay. So the mapping of the branch to which your local branches are mapped to on the remote one, these are your remote tracking branches. Okay. It just means that within this remote repository, my changes, the changes in my local branch are mapped to this particular branch. Okay. And I will show you when we run the command as well, how you can see what are the existing remote branches that you have on your repository. We did git fetch. I will walk you through that. Yeah, sorry, question. Origin main remote traffic. Okay. Yes, they should be available, but I haven't actually checked that like I did with the local branches. But yeah, they should be available within the .git files to keep track of all of those pointers. Okay. Okay, let's go through the second scenario now quickly. Just do a walkthrough of that. Yeah, okay. So let's do the second scenario. As we did the first scenario, just go through the second scenario. So the second scenario is I don't have anything locally. I want to start from scratch. I will create this new repository. Let's call it session 3 demo, something along those lines. Okay. Again, we'll just leave everything to default. I'll create a repository. Okay, so you see now we are in this first scenario where it says create a new repository on the command line. Okay, no, we don't need this, sorry. This is when we started from scratch where we created a Git init and we pushed it. So no, this is not the scenario that we're looking at. We will just have to clone this. So I have this URL and I will come here. Let's do git clone. Yeah. No, so you see, I was just about going to make mistake over here. We check the git status. We are in this, we are already in a git repository, so we can't do a git clone here. I will just move into a remote repo thing. So this is, let me just check if I don't have anything. Yeah, so this is empty. This is not an existing git repository. Yeah, now I can do a git clone. This should probably, yeah. So I actually just ran a git clone. I found an empty directory and ran the git clone command. That was all. Yeah, I was in an existing repository. I was in the demo repository. I just kind of moved out of that and I ran this git clone command. That's all, nothing else. So if I do an ls now, it shows session 3 demo. That's the repository that I just cloned. And if I go into that and I go into, I run a git status. It says no branch main, no commits yet. On branch main, no commits yet. So there's nothing to commit yet. So we've cloned that particular repository. Let's try to add some dummy files here, okay? So I'm only adding some dummy files. And I will run a git status. So yeah, I added 2 new files. And so from here onwards, the process is pretty straightforward and standard. We just commit them and we push the changes. So I'll just do git commit. Okay, these are new files, so I can't just do that. So yeah, I have just added some few dummy files, made some commits, and I'm ready to push. But I wanted to check the Git status over here. Nothing to commit, working tree clean, but look at Git push. So you see, in the second scenario, I did not have to set the connection, and I did not have to set the -u option as well. In this particular case, because I'm cloning an existing remote repository into my local, it already has that information. I don't have to explicitly tell Git all of that. So the second scenario is actually the more common scenario that most of us are familiar with. We start from scratch or from fresh. We create a repository on GitHub and we clone it, and then we start making commits. That's why you don't have to run those additional commands of setting up the connection and telling it that, okay, this is my remote repository. This is my remote repository and branch and remember that. So the second scenario is much more simpler, if you like the term. So no, I didn't have to run the git remote add command over here because the connection was already set up. I just cloned it and I didn't have to run git push origin and then main because it understood by default that I am trying to push to this particular repository. So let's look at your remote -b. So we didn't set up any connection in the second scenario, right? But let's check the remote over here. You see, it already has that information because when we cloned it, it got all of that information. So the remote was already set. And that's why I didn't have to run any of those additional steps. You just clone the information and you can start committing and pushing immediately without having to configure anything additional, as opposed to the first use case where you have a local folder and now you're trying to map, give it all the right information that, okay, this is the address, that this is the destination that you need to push or start sharing information to. Yeah, the second scenario is much more simpler. Now we look at Git. I have to show you one more thing. Okay, so this is Git remote. Let's do first thing. Let's check Git branch. So you see that's the main, but if you want to look at the remote branches, Git branch, I don't know. So that's the only remote branch that we have currently. Now, this is the one that I was explaining it to you. This is called a remote tracking branch. If you have a branch on your local repository, that will be mapped to something called whatever is the name of your remote. In our case, it was origin to the name of the branch. Okay, so yeah, that's the remote tracking branch. If you want to look at your local branches, the command is git branch. And if you want to look at the remote branches that are available, you do git branch -r. Okay. So we push some changes. Let's just refresh this. And you will see it has those dummy files that I just created. Okay. That was the second scenario. Now, within this, I will try and create a new branch. Okay. So how do you create a new branch in GitHub? We know how to do it from the command line. You can use the git switch command, git switch with the -c flag and the name of the branch. But if I want to do it from the GitHub, I'm on main. Sorry, just looking at the chat. I'm on main, and if I want to create a new branch over here, let's say I want to create a branch called session 3, just type the name and it will, and if it doesn't exist, it will give you this option, create branch session 3 from main. So you can click here and create that. Okay, so now you see it has a new branch. What do you think would be the output of this command now? What will I see over here when I run git branch? You can type it in the chat. So no, it will not give you both because Remember, by default, it doesn't know what has changed in which particular repository. And that's why you need to use those three commands, git fetch, git push, and git pull to send that communication across. Something changed on remote doesn't mean it will automatically sync in your local repository. You need to get that information from that remote repository. Similarly, if something changed in local, that doesn't mean your GitHub will have those files automatically and it will sync. That doesn't happen. You have to explicitly communicate and send that information across to the GitHub repository. So if you look at git branch, it just gives you main. So what is the command that I can run now to get that information? There's new information on my remote repository. Yep, that's right. So let's do a git fetch. Let's just run the remote branch as well once. So you see git branch -r, it has it's what it was exactly. We added a new branch in the remote repository, but my local still has the main local branch and the origin main remote branch. So now let's run git fetch. So it tells you, okay, new branch session 3 maps to origin session 3. So that is what this remote tracking is doing. Okay, so this is your remote branch. This is your local branch. What do you think would be the output of this command now if I run a git branch? Correct, because it has that information, but I haven't explicitly checked out that to my local repository. Okay, what do you think would be the output of this command? So this is git branch -r. Correct. It will have both. Okay, so now I want to have the session 3 as well locally. So I have this in my remote repository. I know that. But now I also want to have session 3 in my local repository. For that, we just need to run git switch. Okay. When creating new repositories, we use the -c flag, git switch -c, and the name of the branch. In this particular case, the branch already exists, right? Our local repository is mapped to a remote repository, and we know it exists. In this particular case, if I try to use -c session 3, and let's see what happens. Yeah, it just switched to this new branch. One second, git switch. Let's just do an ls over here. It has both the files. It means creating a new branch, but it would work without the -c flag as well. We can create another one. So let's create another one. Session 3, branch 2. It will work both the ways, even if you don't specify the -c command, because that actually exists in your remote repositories. So I've just created a new branch. Okay, let's run those commands quickly. I will just do a git fetch. Git fetch, let's do a git branch first. So we have those two branches. And if I do a git branch remote, I have the 3 branches. But if I just do git switch without the -c flag this time, session 3, branch 2, even that works. Okay, so it will work in both the cases. You can use the -c command as well. It will just switch. It understands that you're trying to point to this new remote to branch. And even if you don't use the -c, which is the create flag, it knows that this branch already exists and it will switch to that. So if we just look at the files over here, it's the same set of files. Okay, so that's that's how you can look at your remote branches and your local branches, use the fetch command to get new branches as well. Now I will try. Yes, it will make the changes, but I haven't changed. It will make changes in your working directly, like it will implement those changes in your files. That's how I like to think. So if you have a file, and we will do that now. So I will kind of make modifications to certain files on the GitHub repository, and we will fetch them first. You will see it has the information, but the file hasn't been modified. Okay, we'll look at that now. So let's go back to, okay, let's be on this session 3 branch. And I am going to emulate The use of -r is to check the reference of all the branches. The -r kind of stands for remote. So git branch is to see that these are the local branches. And if you want to look at just the remote branches over here, let's run it again. So this is the output. This will only show you the remote branches. Okay. Yeah. No, even if this will, if tomorrow someone goes and adds a new branch and I keep running git branch, I will not know something has changed. You have to run a git fetch to pull any new changes or to get information that something has changed. No, git branch will only show you the local branches. It will not show you the remote. Okay. So let's try to fake a scenario where we have some other contributors. This is my repository. We have some contributors who has come in and modified this file1 text or file2 text. And we will see how we can get those changes. So we're just faking a scenario. So I'm just going to edit this on the UI directly. Some random change, okay? And yeah, I will take that commit message, update file1. So this is, again, the same thing that we do with the recommended commit message. You add a high-level summary, and then you add an optional extended description. In this case, we're not going to do that. I'm just trying to do a demo. So yeah, I just want to make some changes to this particular feature branch. And yeah, commit changes. Okay, so I've modified I've modified this file.txt, but let's look at what this file looks like over here. I'll just do a cat. Let's do ls first. So we have two files. Let's do a cat just means show me what's there in the file. So you see, it's an empty file. We don't have anything. Okay. So first command we will run is, let's do a git status. Okay. Let's see what's there. It says your branch is up to date with origin and the name of the of our branch, session 3, branch 2. So although something has changed in my remote repository, Git still tells me, okay, everything is up to date. You don't have to worry about it because that's the last information it knows about your remote repository. To get latest information, we run a git fetch. Do I have to show you? Let's look at the commit history as well. Yeah, that's the only one that I had, which is called add new files. Now let's run a git fetch. Okay, so it's got some changes over here. Let's look at its status now. So you see, now it starts giving you information. Previously, what did my git status say? Your branch is up to date. Now, what is it saying? After I did a git fetch, I've told my local repository, go fetch information about the remote repository. So now what does it say? Your branch is behind the remote repository, which is called origin session 3 branch 2 by 1 commit and can be fast forward. I'll explain this when we go into pull requests, okay, what this fast forwarded is. So, I mean, you can park that behind, and I will explain this when we are going through pull requests, what these fast forward merge and changes are. So now it says use git pull to update your local branch. We don't have to do that. Oh, we will do the git pull, sorry. So that's git fetch, but let's look at the commits now, okay? Git log. So you see, it still says it has just added new files. The file has actually not changed. If I just open that file again, file txt, you see, there's nothing in that file. It's still empty. Okay. So Git has information that something changed, but our file .text file hasn't changed. And I can show this to you in the Finder as well if it would be easier. Just a minute. Session 3 demo. Yeah, okay. So that's the file, and you see there's nothing in this actually. So this file is empty. Okay. So now we will try and get the changes. I will run a git pull. Was there anything else? No, okay. So it has added those changes. One file changed, there was something inserted. Now let's run git status first. It tells you your branch is up to date with this origin session 3. Let's look at the git log. So now you see there are 2 commits over here. Update file and add new files. So firstly I added new files and then I updated the file.txt. And let's look at the file actually now. So let's cat that. So now you see we added that line and it has picked that up, some random change that was added. So that's the git pull. This is again what the head is pointing at. So your green ones are your local branches and the red ones are your remote branches over here, right? Your head is still pointing to your, if you remember from our first session, your head points to your checked out branch. So whatever changes I will make now will go into head, and my head is pointing to this session 3 branch 2, which in turn is pointing to this particular commit. That's what these red and these green ones mean over here. So the green ones are your local branches and the red ones are your remote branches. That's where it is pointing to. Okay. I will just check my notes. If you have any other questions, feel free to add them in the chat, but checking if I wanted to cover anything related to git pull, fetch, and push. Git remote add. No, I think that's all that I wanted to cover related to these few commands that we covered today. Any questions so far? I don't see anything in the chat. No, it's not empty, the file.txt. Like I said, when I did this cat, I can open the file as well and show you. So this is what the file.txt looks like. Okay, so yeah, it did change. When we pulled the changes, it updated the file. Okay. I'm going to stop sharing my screen now.